All right, we're on to our last section, chapter 10, 10.2, which has to do with regression lines. We're going to look into this, and a lot of this you can do on the calculator, so look for another video, probably come in tomorrow, on the calculator on how to do these regressions. There's some big old long computational formulas in this, and you need to be able to recognize them for the quiz that I've put online, but you can do a lot of this in the calculator, and I want you to see, I'll show you how you can do it. A regression line, the value of the correlation coefficient is significant, and the next step is to determine the equation of the regression line, and that's the line of what we call the line of best fit. If we drew a straight line through the data, you can see here they have three choices. They have three lines, and which one best fits the data. And there's a way to calculate that, but like here's a line that would have a certain slope and a y-intercept, and then here's another line that has a different slope and y-intercept, and then yet there's a third line. And if we look at it, you could say, well, they all fit that data because the data is scattered. It's not clearly linear. There's some scatter in that data. And so we can calculate which one of these would be our best fit line. Best fit means the sum of the squares of the vertical distance from each point to the line is at a minimum. So you try to run your line kind of through the middle of the data so that there's about as much above it as there is below it. And here's the formula. Now on your calculator, I want you to notice this is the formula that is given, which is going to be different on your calculator. On your calculator, what you're going to see when I show you how to do that, it's going to be y equals ax plus b. And the number next to the x, in this case a and in this case b, will be the slope of the line, and the other number here and here is your y-intercept. Remember when you did algebra, this was written y equals mx plus b, where b was the y-intercept, m was the slope, and b is the y-intercept. Now again, it doesn't matter. When you write this, whatever's next to the x is your slope. Whether it's an A, a B, a C, a D, a whatever. For some reason, there's different ways to write it. A then will be your in this case, looking at this line up here, A, because it's not attached to the x, it's not the coefficient of the x, is your y-intercept, and B is the slope of the line. So here's some examples. 10.9, page 553. Car rental companies find the equation of the regression line for the data in example 10.4. Graph the line on the scatter plot. So here's our A, which is our y-intercept. And again, we've got our table. Remember we did a table where we summed up the x's, we summed up the y's, we summed up the x times y's. We got the sum of the x squareds and the y squareds. And so this is our data right here from those tables where we got it, along the bottom, we summed all those up. And then we're plugging in the number, the sum of the y's, the sum of the x squareds, minus, this is your sum of your x, and your sum of your x times y. And then you get 0.396, which is your A, so that goes right here. Then your B, which in this case is your slope. Your B is this equation, and you're going to get, so here's your B, which is right here and right here. Again, that's the slope because it's the number in front of the x, it's the coefficient. And N was 6, and you sum of your x, y's, you notice it's the same on both equations. The sum of the x's is the same because that was, we just took the data and added those numbers up. The sigma stands for sum. if I forgot to tell you that before, and you should have learned it earlier in the course, sigma equals the sum. You're going to add everything up. So we take that and we have our equation, and I always like to write the x first. So y would equal, if I was writing this, because I teach algebra as well, and so I'm used to the mx plus b, and it would be 0.106x plus 0.396. And I am not going to count off if you don't put it in this order, or if you put it in either order, as long as you get the slope in the right place and the y-intercept in the right place. Okay, find 2 points to sketch the regression line. You pick the x, okay? You pick 2 values for x. Now you can get these from your table on your calculator. If you put your regression line in the y equals and look at the graph, then you can go and get it out of your table on your calculator. Or you can substitute a value in for x. It says use any values between 10 and 60. So they picked 15 and 40. You choose. It doesn't matter. And that's the hardest thing I think I have to tell students is they say, where does the x come from? You pick it. You just, pick 2 numbers, draw them out of the hat, whatever. Substitute in the equation and find the corresponding y value. So here we've put in our 15, and here we've put in our 40, and you get 2 y values. So that's 2 points on the line. Okay, these are your x's, right? And you calculated your y's. So this was the calculated value. You calculated this y and this y for those given x's. And that results in an xy coordinate that you can plot on a line. And so then you have this data. The blue dots are the data that was given in the problem. The black dots are the ones that you calculated. And you can see that this line is your line of best fit. And you just go through those 2 points that you calculated. All right, here's another example from the car rental company data. Again, these are all from the last 10-1. And so those totals are in those tables if you want to go back. X equals 20 corresponds to 200,000 automobiles. And so you can look and see that that should be 2.516 billion. And that's a prediction because there maybe not was data right there to get a number. So you make a prediction and its revenue will be approximately 2.516 billion. So this is the same data, the same equation used here, but we just are making a prediction what happens when x is 20. And we get our y. The magnitude of the change in one variable when the other variable changes exactly 1 unit is called a marginal change. The value of slope b of the regression line equation represents that a marginal change. So slope is the key word here. Remember, slope is sometimes a in some of the equations, but it's the number in front of the x. For valid predictions, the value of the correlation coefficient must be significant. So that means it's going to be close to +1 or -1. If it's closer to 0, the best predictor of y is the mean of the data. The line of best fit or the regression line really doesn't apply if your r is not significant, which means this means that your r must be close to +1 or -1. 0.8, 0.9, somewhere in there to be a good, significant correlation. Otherwise, your data is going to be, you can make a prediction, but it's not going to be as good a predictor. Assumptions for valid predictions. For any specific value of the independent variable x, the value of the dependent variable must be normally distributed about the regression line. And so the procedure for finding a correlation coefficient and the regression line equation: make a table. Remember how we did this? We had our x and y. We have our x, our y, our x times y, our x squared and our y squares, and then we go down and we add them up, and you get the sum of each one. Then you're going to use your formulas to find r. Here you're finding r. If r is significant, again, if it's close to +1 or -1, then you find a and you find b. And that will give you the equation of your regression line. And once you do that, then you can plot it on a graph if you need to, but more importantly, you can take it and make predictions. You can pick an x and predict what the y will be at that point. And so that is all there is in 10.2. And we will probably, I will have some regression line problems, but for the most part, they're going to be things you can do on your calculator unless I have you fill in a table. But again, we've got enough material on this test that I don't want you to have a lot of busy work necessarily. So I will make another video on how to do these regression lines in your calculator. So watch for that.